Okay, we're going to talk a little inequalities basics. Inequalities behave very similarly to equations, with a couple exceptions, and we'll take note of that in some later slides. Now, if I start with a statement like 6 is greater than 2, it's a true statement. We all know that 6 is greater than 2. If I was going to perform operations on this inequality, say add the same value to both sides, if I'm adding a positive 2 to both sides of the inequality, when I'm done, the inequality is still a true statement. 8 is still greater than 4. If I were to subtract the same value from both sides of an inequality, the result is still a true statement. So nothing changes. Just like equations, I can add the same value to both sides of the inequality. I can subtract the same value from both sides of the inequality, and it won't change the truth of the statement. Now, if we take a look at dividing by a positive value on both sides of the inequality, when we're done, we get a true statement. If I were to multiply the same value to both sides of the inequality, the result will still give me a true statement. Now, on the last side, let's take a look at if we were to divide both sides by the same negative value. You see that 6 divided by negative 2 is negative 3. 2 divided by negative 2 is negative 1. Negative 1 is greater than negative 3. So you see that the inequality that we had the original had to flip to make this a true statement. So when I divide both sides of an inequality by a negative value, the inequality must flip. If I were to multiply both sides of the inequality by the same negative value, in this case I'm going to use negative 3 here, this will give me a positive 9, this will give me a positive 3, and as we all can see, that 9 will be greater than 3, so once again, the inequality we started with has to flip when we're multiplying both sides of the inequality by a negative value. So if I divide both sides of an inequality by a negative value or multiply both sides of an inequality by a negative value, the inequality must flip. That's the only wrinkle. Otherwise, inequalities behave like equations. Now let's take a look at a simple one. Now I know you can solve this. That's not what we want to practice today. Today we want to practice set builder notation. So what we're going to do here is we see negative 2/5 x is greater than 10. Now x is going to need to be a negative value because I need a negative times a negative to give me a product that's going to be greater than 10. Now in order to isolate it, what we can do is we'll multiply both sides by the negative reciprocal. So here we'll multiply both sides of the inequality by negative 5/2. Excuse me. Let me just rewrite this. So I'm just going to keep going since I'm having a little problems with our explain everything. Now, negative times a negative will give me a positive on this side. Anything times its reciprocal is 1, so I have positive x. The inequality is going to have to flip, and this is going to give me, that will cancel with the 2. 5 times negative 5 will give me negative 25. So here's an inequality we've seen 1,000 times before, and now let's talk about graphing it on a number line. On a number line, we would find negative 25. Let's say that was right here. Negative 27 would be here. Negative 29. Now what we want to do is locate the negative 25 and not actually take that value, but that's going to be our starting point. We don't want negative 25. Negative 25 doesn't make the statement true, but any value of x that is less than negative 25, like negative 27 is less than negative 25, so we'll use that. and we want this end of the number line. Now, set builder notation wants to reflect what is written on the number line. So how we're going to write this, we're going to start with our brace and say any value of x such that x is less than negative 25. This is very easy to do in a simple inequality. Couple wrinkles to the rule when we get to compound inequalities in the next video.